Hi, and welcome to lesson 2, video 3. In this video, we're going to talk about general stock turnover method, which is the stock turnover method we use on most things except for vehicles. It can be pretty broadly applied, and we will also look into where it's applicable and how you actually set it up. If we look back at our little house example from the videos in lesson 1, we'll just repeat how it was, that this is the house. It uses energy dependent on its area and its heating technology and when it was built. So the key factor in this compared to some of the energy intensity method is that it also takes into account when the sale of this product was or when something was produced or built. So the general stock turnover method in LEAP is really well applicable for something like consumer products like heat pumps, fridges, air coolers, lights, freezers, televisions, and so on. In a broader sense, you can also use it for buildings, but it is more difficult. Also because you cannot have stock turnover products inside stock turnover products, so you have to separate buildings as a building, the structure, from the products that are inside it, which we normally don't do in many cases, which we don't do with energy intensity methods last time. But it can be done, and in some places where there's a lot of renewal of the building structure, that actually that does have some benefit. That happens quite often in high growth countries, so that can be done. Now, when we set up a stock turnover method, it's quite simple. We'll set up the different categories that we want, as always. And when we just right click or add with the little plus sign up here, we have a branch we can call the type, and we get the window at the wizard, and we just choose the type called other technology stock turnover method. We give that a name, and we give that a primary consuming fuel, or the fuel it's consuming, and we just start there clicking OK, and then we will then be carried into this, which is the window for the stock turnover technology. We have quite a lot of different parameters, and quite a lot of them it needs profiles. Now, the way that we identify if something needs a profile or not is that we can see on the right side out here that it does say that this uses a stock vintage profile, and right now it's constant. And this is the standard. It will always pick constant when you're making something new. The problem is that is not always a correct answer to give. So LEAP will throw an error if you haven't corrected this profile that fits with the parameter, which can be honestly a little bit of a pain if you haven't identified that from the get-go. So just to quickly show, the different parameters that do need profiles are, as we already see, with the stock, the sales that needs survival, the marginal final energy intensity that needs degradation, I actually think that's it for now. And one of them, the stock, of course, this only occurs in the current account scenario, because that is what looks backwards. So we will just take a quick look of where to find these profiles and how to start making them. So if you see here, if you go up into, the mouse is a little slow with this one, of the general, there's something called life cycle profiles. Now, if you go into that, you can see we have a number of different profiles, and we can also add one more. These are actually these stock turnover profiles. They all mean something different, and I will get more into some of those that are already there. So if you make a test here, stock turnover for AC, click OK. We can see when we do that, we get the general the same as the constant. Now, there is already data filled in, and that can be done either by picking data points, which we do in a second, or it can be done with these exponential linear growth rates version where it actually makes a line for you depending on your formula. Here we can also just pick and choose the actual data points. And how these profile needs to look, like what year 0 needs to be, if it needs to sum to anything, actually depends on which type of profile it is. So it is really good to be very strict about your naming convention, and it's also really good to be very strict or very aware of how your profile needs to look when you start making it, because you can redo these a number of times if you're not quite aware how to do it. The help is not it's not quite as obvious here, because you can do different types of profiles for different things. So the stock vintage profile is the profile that goes into the past, and that means it basically you say of all the products we have of this category, let's call that refrigerators, how many of them are from a year ago, 2 years ago, 3 years ago, and so on. So that means a few things in you. First off is that all these vintages going backwards have to sum up to 100, because it's 100% of the total stocks we have right now. And it also means that the year 0, it has to be 0, because that is the first sales year. So those two would not comply with each other if there were one of them was non-zero. So we have non-zero for sales, we have 0 for the stock vintage profile. So the way to think of it is how many of all the products I have in my system have turned how old. So that's how you go with it. An example from a stock turnover chart is here. You can see how I have the year 0 is 0. It's not quite shown here, but all these add up to 100. It does show that in your profile maker, but not in a way that was easy to screenshot. So I basically have, this is a fairly generally short-lived product. You can see after just around 8 years, we are already down here, but the first year we have quite a lot of them being sold the last 3 years, and then the lack of survival starts taking over. This is actually cars, if I'm not wrong, in this case, passenger cars. And after 16 years, barely any of them are left. So in this case, 0% as we have defined, coming from our statistics. The statistics for your stock turnover, depending on your products, can be quite difficult to actually gather. You could gather something with finding out how many products have been retired versus how many products have been sold. That's a way of doing that. If you have any form of tax system on them. But generally with consumer products, there are some academic sources of their general survivorship. And the way that I found these statistics is I mainly use a general survival profile, or find a survival profile for this kind of product category, fridges, TVs, whatever it is. And then I try to find the sales numbers of going years back. And then I can say, depending on so if a product was sold 10 years ago and it has a survival profile that says within the next 4 years only 50% are left, well, then 50% of that vintage it left after 4 years, and now we're 10 years later, then now it's probably less than 2 years, 2% of them are left. So then that would mean that 2% of my my vintages are 10 years old, and so on, for going further. So that's usually how I try to find these, but it can be quite difficult. It also depends a lot on the statistics and how much of it happened, how obvious the statistics are. Other than that, depending on your country or your region, import statistics might be good for this. There is some countries that basically have import numbers for the number of heat pumps imported, and if you don't have your own production of that, that is the same as sales, basically. So that is that's quite useful as well. In a country like Denmark, where I'm from, then we also have the same thing. We don't produce TVs in Denmark, generally speaking. So if you have the import statistics going number of years back of the number of TVs that has been imported in Denmark, that translates directly to the number of sales that has been done in Denmark, which is quite nice. Then going forward, in our projection scenarios, we have our sales survival profile. So the best thing about the structural method is that we can define sales per year going forward, and we can play around with that. That's usually how we do with different things. But that also means to have a survival profile, and what the rules are for that. So the rules for the survival profile is generally pretty good, or pretty easy. So the year 0 is always 100, because if they're less than 1 year old, we assume they are all still there. Or you can also say you round up, so that's just really new products. Then I think I didn't write that, but of course, since it's a survival profile, every year after year 0 has to be less than 100, which means it's a general profile that goes trending downwards, and it can never increase again. Then you have the error, because you don't get it magically more that are a certain number of years old. Now, of course, something to remember is in this survival profile, that is the product's life cycle time. So if you have a product like a TV that changes hands, like gets sold on a used market 3 times, well, that's still within the lifetime. It doesn't really matter who owns it, just that it is still active and within this. That could be something like scooters that gets multiple repairs, and then they last for 15 years, even though nothing is almost the same. If you just define it as scooters, it will still just last 15 years. So, and then you could maybe approach this number of how old the different components is in different ways. And then the general method of looking into this is of the numbers that were sold in a certain year. This could be this year or year 2023 or 2030 or forward. After a certain number of years, for instance, let's say year 8, how many percent are left? That's that question mark. So if that's, let's say 70%, well, that's what you write for year 8 and going downwards. So that's how you define the sales survival profile. And here we see an example of a profile for sales survival. And we have a few more of these, so we'll put them over on top. And they work. So we can see here that we have now 3 different profiles. So in this example here, we have 3 different products that they all start in year 0 in 100. They all, in this case, goes for 25 years. That is depending on what you want to do. If you don't have enough years, it does throw a warning, but not an error. And I think it will have a flat line further out if that's what you have to do. But you can always tell it to add more years. So you can see in this case, I think this is also vehicles as well. This is trucks that we see we have a very mild slope. And after even 25 years, we still have about 40% left of the sales. So they last for a long time, see a lot of repairs. For personal vehicles, it's quite a lot less that's left after 25 years. And this being motorcycles, after around 13 or 14 years, we basically have none left because they don't last as long and it's a simpler product. So this, we can also show how to have differences in how long lasting the different technologies are. And that's what we use the survival profiles for. In the third profile we always need to use, it's the degradation profiles. So the rules for the degradation profile in the normal or the general stock turnover, it depends a little bit in terms of units for transport, we'll get to that. But for the general one, then, well, year 0 is always 100. So in the first year, it retains all of its original energy efficiency. And then after that, it does trend upwards. So we have a profile that goes up in some way, all depending, because it is the energy intensity of the product. So how many kilowatts for instance, how many kilowatt hours per activity per square meter that this product is using, and that the higher of that number, the worse it is. So it will trend upwards as time goes on. So after how many years, how much in terms of energy intensity have my product degraded? So after 8 years, is it plus 10%? And then it's 110. That would be the right answer here. Makes sense? It's just very simple linear. So this could be an electrical product. These do not degrade quite a lot these days. They more often break before they have degraded quite a lot. But in this case, we say after 25 years, it has degraded to be more 10% more energy consuming per activity. So that's a 10% increase in the energy intensity for the product. So that's what we show here. And again, here we've just chosen a linear method of doing that. And that could also be a growth, or it could be something else. It might even have a lessening effect, never going downwards, but lessening effect the longer the time goes. Can't think of a single product who does that, but there might be some. So as you saw before, there are quite a lot more different parameters we can use, and I want to touch on them a little briefly. They're not often used. We're not going to look much into them. They're not going to show up in exercises at all. But of course, so we have there's max scrappage fraction, but actually that belongs to something called scrappage. Then we have usage factor, and then of course device share. So device share is quite easy. It's just a share of between two competing technologies in this case. So it is if you have a technology that can run multiple fuels, kind of like a plug-in hybrid, but for a different setup too. So if you have maybe an oven and gas cooker combo, so that could be both gas and electricity, and then what is the share of the gas part and what is the share of the electricity part, because even though it is just one product, it can be used multiple fuels. That's the device share you can define there, and you can do that just by adding another fuel, and we will get to that as well within this lesson. Scrappage is more interesting. So in terms of scrappage, that is we also call it forced retirement. So instead of naturally retiring or exiting the system by not being functional anymore, as we see in the survival profile, we can actually set policies where we say, actually we are going to take the worst products and we're going to force them to exit, even though their survival profile may say that they shouldn't do that. So that is a way of telling the model that if we put this for survival to being 150 units per year, it will find the oldest units and then forcibly retire those. That is so that's the 150 oldest that gets retired. And then you can also set a max. You can set that either to a fraction, so you can say that it's instead of a certain number, it can be a certain percentage, like take the worst 10% and replace those or retire those. And with the max fraction, you can also say if it's a fixed number, well, take the 150 oldest unless that's more than 10%. For instance, that's then you can choose between those two as well. The usage factor, I honestly don't quite remember. I will put that in the Q&A somewhere because I've never really used it. And then of course, first sales year, you can actually set a different sales years than the general, but I have never tried where we didn't put the general in. But that's when we start with the analysis with the with setting in the stock turnover part, sales part. So you could move that back and forth depending on where you have statistics, or if you think something isn't going to be happening until a few years forward. And then demand cost, that is just the related to demand, which we will cover in lesson 3.